Hello ladies and gentlemen, welcome back. This is Ms. Dubois doing another video for Pre-Algebra Goal 2. We're going to be talking a lot about multiplication and division, and specifically, now that we're comfortable with our four major operations, addition, subtraction, multiplication, and division, we're going to talk a lot about order of operations, and then to round off, we're going to do dip our toes into handling fraction multiplications and trying to make something that scares all of you guys even just a little bit easier for you all. So, to begin, before I even scroll down to topics, I want to talk a little bit about order of operations. Again, this is probably something you have seen in middle school, so please excuse my dear Aunt Sally, which is parentheses, exponents, multiplication, division, addition, and subtraction. So, that is the order, the literal order in which you do your operations. You start with your parentheses and then fight your way down. And this comes up in, as you can see, a lot of different topics because we're getting you used to all of the different iterations of it. And we're going to kind of go through step by step, get you comfortable with it in pieces at a time and understand how this is going to work. So if I scroll down, I should have given myself enough space. Please excuse my dear Aunt Sally. I always write it a little bit differently because I like doing multiplication and division. I tend to end up doing that when I'm doing the hypermath in my head, the human calculator stuff, kind of all in one go. But first, before we do order of operations, let's get you used to one of the new letters. That is called exponents. Exponents is, if multiplication is repeated addition, then exponents is repeated multiplication. So if I'm looking, and I'm going to use this one as an example, if I have negative 4 squared, that is negative 4 times negative 4. And especially for beginners here, I do recommend you write the problem out however often they tell you, unless it's something obnoxious like to the 21st power, just to get you visually used to what exponents mean for you so you can mentally, wire your brain and get yourself used to the expectation. For this one, a negative times a negative is a positive. 4 times 4 is 16. This one is negative 7 times negative 7 times negative 7. Okay, so negative times a negative is a positive. Positive times a negative is a negative. So my final answer is going to be negative. 7 times 7 is 49. And now what's 49 times 7? That's going to be, I don't actually know. I'm tired, and that means I can't do math in my head. 7 times 9 is 63. 7 times 4 is 28. 28 plus 6 is 34. Oh, 343. I should have known that. Silly Ms. Dubois. I'm mad at myself. But that's how you're going to be going through and doing your multiplication. So this one, so we have negative 3 times negative 3 times negative 3. Double negative is a positive. Have another negative, and that's going to be a negative answer. 3 times 3 is 9. 9 times 3 is 27. This is negative 6 times negative 6. Negative times a negative is a positive. 6 times 6 is 36. Negative 3 to the 4th power, so that's negative 3, negative 3, negative 3, negative 3. So negative times a negative is a positive. Negative times a negative is a positive. Positive times a positive is a positive. Huzzah. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. This one, for once they didn't throw a sign at us. Good job. So it's 5 times 5 times 5. 5 times 5 is 25. 25 times 5, aka, what's the value of 5 quarters? 125. Now, again, because we're getting you used to all of the exponents before we start throwing the Pemdas at you. So that's negative 6 cubed. So now we have negative times a negative times a negative. Or no, I should keep writing this long form. Just because I can do this in my head doesn't mean you guys can. So negative 6 times negative 6 times negative 6. That's a double negative. With that is a positive. And then with the third negative is a negative. And now 6 times 6 is 36. 36 times 6 is 180, 218. So 218. Then this is, now this one's tricky. Look at that. You have the negative not inside the parentheses like they had before it. You have your negative outside the parentheses. That's really important because that negative stays outside of all your computations. So we have 2 times 2 times 2 times 2, and then you're slapping the negative on at the end. That's very different from using the negative in your computations. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and then the negative gets slapped on in front. Negative 2 cubed, so that's negative 2 times negative 2 times negative 2. So negative times a negative is a positive, positive times a negative is a negative. 2 times 2 is 4, 4 times 2 is 8. Not so bad. This one is 5 times 5 times 5. Once all of that is done and taken care of, we slap a negative in front. So 5 times 5 is 25. 25 times 5, aka the value of 5/4, is 125, and then we slap the negative on in front because it finally has something to do. Same thing. Our goal 1 video problem happened. We have pasting of data here. We have negative 5 cubed listed twice. Why did they do that to us, software? Why did you do that? So that's going to be negative 125, and we don't have to think about it, apparently. This one, although this one's new, I think. So we have negative 3 times negative 3 times negative 3. Negative times a negative is a positive. Positive times a negative is a negative. 3 times 3 is 9. 9 times 3 is 27. And now that we're comfortable, or at least have some exposure to exponents, now we get to talk about Pemdas more specifically. So when you're going through these problems, and I'm going to write it again, parentheses, exponents, multiplication, division, addition, and subtraction. You always start, now for these topics up here to begin with, we don't have any parentheses or exponents either, so we can kind of mentally cross these off for now. We're looking specifically at the multiplication, division, addition, and subtraction. And you'll notice we're doing the multiplication and division first. What I like to do for the beginners is I tend to highlight them first and keep them a little bit separate, Ms. Dubois, honest to goodness, so that I know that those are the things that I'm pairing off first. So looking at this, what is 2 times 4? That's 8. What is 24 divided by 4? That's 6. And now that's a lot easier to read in my brain space. 9 and 8 is 17, 17 and 6 is 23. That's easy enough to do in your head. And now the same thing here. We have 2 times 5, and then we have 24 divided by 4. So 2 times 5 is 10 plus 5. What's 24 divided by 4 is 6. 10 plus 5 is 15. 15 minus 6 is 9. The highlighting I have found for a couple of students, the few times that I've managed to teach this, actually seems to be a game changer for them. If you're someone who doesn't have a lot of highlighters or colored pens, you can use different kinds of underlining. So when I was growing up, I didn't really have a whole lot of pencils. I just had like the one mechanical pencil that I think I still have somewhere in the apartment. So I would just do underlining, so I'm going to do those first. 18 divided by 3 is 6. 2 times 4 is 8, and then minus 3 plus. 6 minus 3 is going to be 3. 3 plus 8 is going to be 8. 18. Ms. Dubois, what the heck did you just do? My brain short-circuited. There you go. Your final answer is 11. Now that we have a little bit more comfortable with multiplication and division, now we're going to talk about grouping. The thing with the parentheses is you think about parentheses like a layer. It's in higher level math when you start getting into like algebra 2 and pre-calc and really some of the junior senior stuff with the groupings and the parentheses, we call them nested. So you have parentheses nested inside parentheses, nested inside parentheses. You always start with the one that is the most inside first. That's how you do it. So when I'm looking at this one down here, I have that parentheses and that parentheses. And sweet Jiminy Cricket, the horror, what do I do? That one is the one that's the most inside, ergo, that's the one that I do first. So 42, I'm not touching, divided by 1 plus 2 times, what's 18 minus 15? 3. Then inside the parentheses, I have a couple of things to do here. I have the plus, and then I have the 2 times 3, which means I'm going to do the 2 times 3 first. 1 plus 2 times 3 is 6. And now what is, in fact, 1 plus 6? That's going to be 7. And what's 42 divided by 7? 6. Next, there's my innermost parentheses. So those are the ones I'm going to start with. So 6 plus, what's 17 plus 4? Brain, 21 divided by 7 times 2. So now I have addition and division here. Knowing my order of operations up here, we're going to do division first. So that's 6 plus 21 divided by 7 is 3 times 2. 6 plus 3 is 9 times 2, which is going to be 18 is our final answer. We start with our innermost first. So 17 plus, what's 16 minus 7? 9 times 2 divided by 5. So now we have addition and multiplication here. And again, looking at this, we do the multiplication first. So that's 17 plus, what is 9 times 2? 18 divided by 5. What is, okay, 17 plus 18, oh, is 35. So what is, when I do this out, that's 35 divided by 5, which is, of course, 7. And that's going to be your final answer. I don't feel like I explained very well. I was just more focused on doing the math, but you guys got to have the chance to watch me sort of solve live and in person. So hopefully that gave you some tips and tricks. So now more order of operations. So let's rewrite my Pemdas so I don't lose track of it. All right. So now we're going to have some exponents thrown into the mix to make us feel a little bit more comfortable with it. And again, we're looking to do the exponent. It's the inside the parentheses. And if I have the choice between a plus and an exponent, I'm going to do the exponent first. So that becomes 8 plus, what's 2 to the 4th power? 2, 4, 8, 16 divided by 4. And now I can do the parentheses first. 8 plus 16 is 24 divided by 4. 24 divided by 4 is 6. Final answer. Now over here, you'll notice that the parentheses is on the outside. So we're not going to touch that yet. We're going to actually outright ignore it for half a second. Because again, the parentheses come first. So what is 1 plus 4? 5 squared. And now we're ready, because now there's nothing else inside the parentheses. We just have the 5, so now we can look outside of it. We have the multiplication, sure, but we also have the exponent, and the exponent gets priority because of the order of operations. So 5 squared is 25. And now what's 3 times 25? 75. And now mix it up again. We have that squared inside the parentheses, so that's what we're going to do first. Divided by 18 minus, what is 3 squared? 9. Okay, and now parentheses come next. So what is 18? Whoa, computer, what'd you just do? There. What's 18 minus 9? That's 9. And what's 99 divided by 9 is going to be 11. So now, so that's the setup. That gets you comfortable. These ones, this is where the math nerd in me starts to come out. I kind of love these ones. The more complicated they are, the more fun they are for me, because it's a challenge to figure out the order that I'm supposed to do it. And it makes me happy because I'm a nerd. This is why I teach math. Now, order of operations with exponents. Okay, so here we want to be a little bit more intentional, because I know the negatives can drive some kids up the wall. And I remind you, when you're looking at your operations, do the sign stuff first. So when I'm looking at this and I want to pick what I'm starting with, we have multiplication first. That's good. We have specifically a negative times a negative, which is a positive. And then what's 3 times 4? 12 minus negative 6. And then we were talking about this in goal 1. Negative, negative, double negative is a positive. So 12 plus 6, your final answer is going to be 18. Over here, we're looking for our multiplication first. So the negative 24 drops down because we're not touching yet. And then what is negative 18 divided by 6? That's going to be negative 3. And now we're ready. We have the addition. Same sign. So we add. And therefore 24 plus 3 is 27. What's the sign of this number? Negative. And that finishes us off. Next, again, we're going to do the multiplication first. So the negative 4 minus stuff drops down. What is negative 20 divided by 4 is negative 5. And then we have the double negative, which is a positive, so that gives me negative 4 plus 5. Those are opposite signs, so we subtract. 5 minus 4 is 1. 5 is the bigger number, so that's the sign that dominates. And that's how it works. Okay, and I believe that's everything to do with order of operations. And we've done a lot of different permutations and iterations, so we're going to take 3 seconds to breathe. And now we move on to the next thing, which is very specifically going to be talking about fractions. So again, we were talking about this in the last video. I no longer read that as a fraction. I read that as division. So what it's asking is, what is 63 divided by 7? And in this case, the answer is 9. What is 24 divided by 3? And the answer is 8. And I'm getting away with it right now because the numerator is 1. We'll talk about that in a bit. We'll worry about that later. What is 42 divided by 7? That is going to be 6. And that's our final answer. Because again, fractions are now replaced with division. Division. I cannot emphasize that enough. It will make your life so much less stressful. So let's actually take that and apply it to our test. To remind yourself, 49 as a whole number is always over 1, over 1, over 1. And here's a little trick that we're going to do, because I know we're going to have division in here. I'm going to do a quick little bait and switch. Is 7 times 1 different than 1 times 7? Take a minute and think about it. Is 7 times 1 any different than 1 times 7? And the answer is nah, miss. That's the same thing. That's the point. Because I know that they're the same thing, I'm going to do a quick little, and here's the fancy word for it. We're going to do the commutative property of multiplication, but that's goal 4. What we're going to do is we're going to replace that over 1 to make it 6 over 1 times 49 over 7. And since we now know fractions are division, to make life easy for us, what's 49 divided by 7? That's the kicker, and that's what makes this kind of cool. You can now effectively cross this out and say, okay, yeah, sure, that's fine, but what's 49 divided by 7? It's 7. And what is 6 times 7? 42. And lo, the human calculator did a human calculator thing. Ha 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 ha. Same thing again. I'm going to switch the 7 and the 1. So 2 over 1 times 56 over 7. What's 56 divided by 7? Fractions are division. So what's 56 divided by 7? 8. What's 2 times 8? 16. Over here, same thing again. I'm going to do my little bait and switch because I know that 56 and 8 can be divided. So that becomes 7 over 1 times 56 over 8. Fractions are division. What's 56 divided by 8? 7. So what's 7 times 7? 49. So for those of you who are constantly impressed with my human calculator, this is all I'm doing. Literally, this is all I'm doing. What's actually happened, and I'll take it a step further. Let's do something like, I'll do something a little bit shorter. 2/3 times, what's a nice whole number? 18. I am now to the point where I don't even do the bait and switch of flipping the number. I just look at the 3 and the 18 and I switch it over to 6, and then 2 times 6 is 12. And sometimes I'll actually write that in the notebook because I'm more thinking the math out loud than I am actually explaining that. I am working on that this year. But that's how this trick right here that I've just gone through to show you is what I'm actually doing. Now for fraction to fraction multiplication, here's the rule of thumb. We're going to be multiplying across. So 8 times 4, 9 times 7. And since this is the introduction, we don't have any of our fancy tricks like we were doing up here. Hold that thought. So 8 times 4 is 32. 9 times 7 is 63. 3 times 8, or no, wow. 3 times 6 is 18. 5 times 7 is 35. 2 times 2 is 4. 3 times 7 is 21. Excuse me. That's the introduction part. All you're doing is multiplying across. The really fun stuff doesn't happen until a little bit later. A little bit later meaning right now, fraction multiplication. Now, again, because I'm really trained where I can just kind of look at numbers on the diagonal, That's what my brain is going to do right now. I'm looking at those two numbers on the diagonal. I'm looking at these two numbers on the diagonal. Heck, I'm even looking at these two numbers on the diagonal now that I'm actually looking, and some cool stuff is kind of happening. So what I'm going to do is I'm going to pull my bait and switch trick. I'm going to flip my 9 and my 2. That gets me 3 over 9 times 4 over 2. And because this is division, what's 4 divided by 2? 2. And that's over 1. 9 over 3, that one's still a fraction because the 9's in the denominator, but as a fraction, that simplifies to 1/3. So let me rewrite that. We were able to simplify this to 1/3 times 2 over 1. And those numbers are a heck of a lot easier to do in your head. 1 times 2, 2. 3 times 1, 3. There's my answer. Same thing over here. At a glance, I can see that the 10 and the 2 are easily divisible, and I also looks like I have another 3 and 9. So I'm going to perform my little bait and switch trick. I'm going to flip the position of these two numbers. 10 over 2 times 3 over 9. Now the 3 over 9, we already know from over here that this is going to become 1/3. What's 10 divided by 2? 5. So that became, let me rewrite that, 5 over 1 times 1 over 3. Multiply across, 5 times 3. That's how I'm doing this math hyper fast in my head. And honestly, that's why fractions for me are a heck of a lot easier, because this little cheat, this little hack makes the math easy for me. Decimals, I still can't wrap my head around decimals. That's harder for me because there's only the one method, and that makes it annoying, and we'll talk about that when we get there. Let's see, I have the 2 and the 4. 3 and 7 don't simplify, but I'm okay with that because the fact that I'm getting any simplification at all, I low-key kind of like. So I'm going to do my bait and switch trick. I have 3 over 7 times 2 over 4. 2 over 4 simplifies to 1/2. So 3 times 1 is 3. 7 times 4 is 14, and that's its most reduced form. Let's see here, 4/9 and 3/2. So those can cross, so I'm going to perform my little bait and switch. 4 over 2 times 3 over 9. This looks familiar. Did we already do this already? So 4 times 2, 4 over 2 becomes 2. 1/3 becomes 1. No, 3 over 9 becomes 1/3. I shot ahead of myself there. So 2 over 1 times 1 over 3. 2 times 1 is 2. 1 times 3 is 3. And that's another little mental math hack for this. And sometimes they give you more than one fraction. So finding your place to bait and switch can be a little bit tricky. So if I'm looking at this one, I definitely see that the 7s can line up. But I don't see any other really good pairs. So eeny, meeny, miny, mo, I'll bait the switch, the 5 and the 7. So that gives us 7 over 7 times 1 over 3 times 5 over 8. 7 over 7, shockingly, that's division, remember, is 1. So I'm just left with 1/3 times 5/8. 1 times 5 is 5. 3 times 8 is 24. Over here, let's see here. I like the 7 and the 14. I know those will divide, so I can bait and switch those. I like the 3 and the 15, so I'm going to try to bait and switch those as well. Now, you'll notice I made different shapes for these because when I do my baiting and switching, when I move my numbers around, I want to make sure my shapes match. So that gives me 3 over 15 times 7 over 14 times, what's my leftover numbers? 11 over 2. So 3 goes into 15 5 times. 7 goes into 14 twice, and the 11 we can't do anything about. So that's 1/5 times 1/2 times 11 over 2. That's a lot easier to look at, isn't it, huh? So 1 times 1 times 11 equals 11. 5 times 2 times 2 is going to be 20. 11/20ths. So let's see here. Are there any other good ones? We have... did we seriously just copy and paste the problem again? What is with this software and giving me the same fractions? That's frustrating. That means I have 3 examples instead of 4. All right, let's see here. We have the 7 and the 7 4 doesn't match, 1 doesn't match. All right, so this is the only bait and switch we have. So 7 over 7 times 1 over 5 times 4 over 9. 7 divided by 7, 1. 1 times 4 equals 4. 5 times 9 equals 45. And there's our final answer. All right. Now, almost wrapping up. We still got a couple of topics left, but a couple of kids have pointed out to me that they look at this particular topic and they're like, Miss, what now? What? So what you want to kind of do, let's see here. We have our 8 over here, and how many of them are we shading? We're shading 7 of them. So what I'm going to do is I'm literally going to do that. I'm going to shade in 7 of them. Next, we have, oops, wrong direction. We have a 5th over here. How many of them are we shading? 3. So 1, 2, 3. That's the start of a rectangle. So I am just going to go through and shade in my rectangle. Make it nice and big and obnoxious. So now here's the question. How many of those boxes did I shade? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Which is convenient because 7 times 3 is 21. And then how many boxes are there total? Well, what's 8 times 5? 40. That's what they're expecting you to do for this topic. Same thing over here. We have how many thirds? We have 2 of the thirds. And then we have 2 of the fifths. Make their little box right there. And then what do we have? 2 times 2, we have 4 boxes shaded. How many total boxes are there? It's a 3 by 5 grid. 3 times 5 is 15. Over here, how many ninths do we want? We want 2 of them. How many fifths do we want? We want 4 of them. Now we can shade in our happy little box. And how many do we have shaded? We have 8. How many total are there? That's a 9 by 5 grid, 45. That is how you're going to be doing this topic. Now, if you'll notice, we're at the end of the page, but we're not actually at the end of the problems because we had a couple of more things highlighted here that we haven't actually done yet. So I'm going to delete this for a second, and we are going to turn this layer and turn on the next layer. So now we get ready to talk about, that was modeling that we just did, and now we get to do the last couple of topics that are on this particular video. So looking at this, what have we got? We have signed fraction multiplication. So this is everything we've been doing. We're using all of our skills now with the added benefit of, you guessed it, signs. And what do we do first? Signs, because we need to read those signs, because you need to know your signs. Yeah, this joke is going nowhere. Okay, moving on. So we have a negative times a positive. So my answer is going to be negative. That's 5 over 1. Does my bait and switch trick work here? 4, 5, 7. No, it doesn't. So 4 times 5 is going to be 20. 7 times 1 is 7. And there's our final answer. Here, a negative times a negative is going to be a positive. Do I have any bait and switch numbers here? Ooh, yes I do. I have the 4s. So just really quick, we're going to switch that out to 4 over 4 times 3 over 5. 4 times 4 is 1. So 3 over 5 is just literally all we have. So we have 3/5. Let's see here. Negative times a negative is a positive. That's going to be my final answer, so I don't have to worry about the signs anymore. Do I have a good bait and switch? Yes, I do. I have the 8 and the 2. So let's switch that out. 8 over 2 times 7 over 1. Now again, fractions are not fractions anymore. They are division. So what is 8 divided by 2? 4. So 4 times 7 is going to be 28. 1 times 1 is just going to be 1. Negative 28. Okay. Next. Now we get into the word problems. I can see how thrilled you are. I hear the groans from here. Let's see here. Word problems involving fractions and multiplication. I'll be honest though, the fact that the word multiplication is like literally in the title, that kind of gives it away. So we have 6/7 of a spool. He used 3/5. So how much was used of the project? Let's see here. 6 and 5. That doesn't work. 7 and 3. Does that work? No, it doesn't. So we're just multiplying across. 6 times 3 is 18. 7 times 5 is 35 because we couldn't use our little bait and switch trick. What about this one? 8 over 9 times 2 over 5. Can 8 and 5? No. Can 2 and 9? No. So this one is another one that does not have a bait and switch trick to it. So we're just going to multiply across. 8 times 2 is 16. 9 times 5 is 45. All right. And now, oh no, I see the word multi-step. I can hear you guys groaning from here. So let's see here. There were 90 runners on a race to start. In the first half, 2 of them dropped out. Okay, so we need to take out 2/5 of our runners. That's going to be 90 minus the 2/5. We'll talk about that in a second. And then in the second half of the race, 1/3 of the remaining dropped out. Okay, so we have the 2/5 for the first half, and then we have the 1/3 for the second half. The next question then begets is, what are we multiplying it with for? Because we know multiplication is being used in here. It's literally in the title. So if we're taking rid of the first half of the race, half of them, who is the them? The 90 runners. So what is 90 times 2/5? So I can do my bait and switch because that ends in a 0, which means this is divisible by 5. So 90 divided by 5 is 18. Okay, what is 18 times 2 is 36. Now you'll notice I didn't do this in the long format of my bait and switch. I'm doing this in my head because I stupidly didn't give myself enough room. So what is 90 minus 36? 54. So 54 is my new number, and now I have 1/3 of those dropping out. So it's 54 divided by 3. Yes. Oh, it's 18 again. So what's 36 minus 18? Yeah, what is 36 minus 18? That is 18, and 18 is going to be our final answer. These ones are a little tricky because when they say multi-step, they really do mean multi-step. It takes a hot minute to get the work out. Let's see here. There are 63 students in the speech yesterday. 1/3 of them gave their speeches. So 1/3 of them being the 63. So I know the setup there. Today, 2/3 of the remaining. So 2/3 of the remaining. We don't know the remaining yet because we need to do this computation first. And so I'm going to do my bait and switch. So I'm going to flip my 3 and my 1. What is 63 divided by 3? That is 21. And so what is 63 minus 21? 42 over 1. Now, does that simplify? Does 42 and 3 divide evenly? It does. So I'm going to bait and switch for a second. I'm going to switch that to a 3. I'm going to switch that to a 1. What is 42 divided by 3? 14. And what is over 1? What is 14 times 2? 28. Okay, and what is 42 minus, what is 42 minus 28? That is going to be 14. 14 are left. Okay, I think that should cover everything for this particular topic. This is one of those topics where honestly you're going to kind of want me sitting next to you to walk you through it. It is just multi-step enough where even Ms. Dubois, the trained math teacher, has to kind of like mentally double check her work as she's doing this live in front of the camera. And then determining if the quantity is increased or decreased when multiplied by a fraction. I've had a couple of kids come to me with this problem, and then when I explain it, they're like, wow, miss, it's really that simple? And yes, it's going to be this simple. What you're doing is you're looking at your fraction. 72 over 72 is 1. Any number times 1 is itself, so it's going to be equal. 46 and over 47, that's a fraction that is smaller than 1, and since it's smaller than 1, the product is less. 1/39, well, that's pretty obviously a lot smaller, so that's going to be less than 1. Sometimes they will give you something like 19 over 18 times, whatever their obnoxious number is, so like 321. You'll notice 19 is bigger. This means this is a number that's more than 1, so the product will be greater than 321. That's what they're trying to kind of train you to do. And we'll do it again. Oh, there's an example of it right there. You have 94 over 85. That's an improper fraction, which means this is going to be greater than 1. That number is exactly 1, so it's going to be equal. 74 is bigger than 73. That's an improper fraction, so this is going to be greater than the 641. And at last, that is all of the topics for this particular video. We've now covered a lot of work with order of operations, and we just did a small mountain of work with fractions and fraction multiplication. Hopefully this will help you go through, burn through those topics. You'll probably be due for a knowledge check in the middle of all of this and start burning your way through goal 2. As always, thank you for joining me on this journey as I try to do all of the pre-algebra videos. Stay happy, stay healthy, stay safe, and I will see you in the next one. End transmission.